Okay, there it is. That noise means we're recording now. Okay, so no swearing. All right. So anyway, we've got a half curly arrow and a full curly arrow. What I'm going to do for the recording, I'm going to go to the top, and then I'm going to scroll down a bit slowly. We started here, didn't we? That was the first page. This is just for the recording, you two. All right. Okay, there's the second page. Okay, so for your notes, all you've got to go to is YouTube. And if you go to YouTube, you'll be able to see this. All right. And then I'll push that up to there. Okay. And then we talked about bond breaking, heterolytic and homolytic, and how bromine breaks apart. And then we looked at how HCl breaks apart there. And now we're looking at curly arrows. All right. And that's what we're doing. So a full curly arrow shows 2 electrons, and a half curly arrow is 1 electron. So how would I show this then in an equation, I guess? So we've got bromine here. This is how it all started, if you remember. We started off with bromine, and bromine forms a BrX and a Br dot. Let me put all the other electrons in. Here we go. All right, so we get X, 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 and O, 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 O. All right, now there's the equation we did earlier, and now let's use my curly arrow. Well, what happens? The bond was here, and 1 electron went this way. Oh, that's not nice, is it? It's pretty ugly. 1 electron went to the right, there, and the other electron went to the left, there. So this is a use of a half curly arrow. This is a half curly arrow because I'm showing the movement of 1 electron. One goes one way, one goes the other way. Half curly arrows are shown when free radicals are formed. All right, free radicals are formed. And the type of fission for half curly arrows is homolytic fission. Okay, and we get over here, we get free radicals. Free radicals. Okay, there we go. So that's how the half curly arrow works. Let's have a look at the full curly arrow. Okay, I'm going to use a different color, and I'm going to use my other example, HCl. Okay, and there's the HCl molecule. Now, how did this split up? Well, it split. Is that a word? It split up into these 2 things, didn't it? Okay, and these things had charges. So this was positive, and this is negative. All right, and now these 2 electrons, both of these electrons ended up on here, on my chlorine. So this is a full curly arrow. This is a full curly arrow, and we get ions formed. Okay, and what type of fission is this? Well, if you have a full curly arrow, you have heterolytic fission. Okay, so are we all good there? Is that good, you two? And don't forget, we're recording this now, so we're good. Well done, Janet. Dimani, how about you? You good? He's gone. Quite understandable. How do you use quite in this context? Quite as in fully, or quite as in a bit? Oh, well done. So you're good. It is understandable. It's lovely. It's a lovely topic. It really is. All right. So now all that's done, and now what we're going to look at is what's called a reaction mechanism. Okay, and this basically says, a reaction mechanism is how does a reaction take place? It'd be nice if I could spell. How does a reaction take place? What are the steps? Okay, where do the electrons go in a reaction? Okay, now this is basically, we've done a lot of work today, but we're going to, this is the main part of the lesson, if you like. Okay, and the reaction we're going to look at is this one. We're going to look at methane, which is a gas. I'm going to react it with chlorine, which is a gas, and it's going to give me CH3, Cl, which is a gas, plus HCl, which is a gas. Now, what are these guys called? Well, this is obviously called methane. This is called chloromethane, because there's a chlorine on my methane. And the last thing is obviously HCl. All right. So this reaction will happen only, I don't know about only, but it will happen in the presence of ultraviolet light. Do you remember this reaction from last year or 2 years ago when you did IGCSE? Do you remember how you made this reaction happen? Anyone remember? How did you make methane react with chlorine? You put it in ultraviolet light, but we wouldn't have done ultraviolet light then. What did your teacher say in those days? Do you remember? He may have said ultraviolet light, but mostly teachers in Form 5 say sunlight, because it happens in sunlight. All right. Now, this reaction happens in sunlight. There you go. So what we do is we have these things on the left, and we zap it with sunlight or ultraviolet light, and the reaction happens, and it's very quick. Once it gets going, it is fast. It's explosive, in fact. It's a very fast reaction. So, but now what we're going to do is we're going to look at, well, what actually happens? Okay, and what actually happens is known as a free radical substitution mechanism. Okay, so we're going to look at what's called a free radical mechanism. Okay, now this is enjoyable. I think this is fun. I think you'll enjoy it. The first thing that happens is a Cl, a chlorine molecule, splits up into a chlorine free radical and another chlorine free radical. Okay, that's the first thing that happens. So now I've got to use my curly arrow, and one of these electrons goes onto this chlorine, and one electron goes onto this. This reaction happens in ultraviolet. That's not the right color. This reaction happens in ultraviolet light, or, as we said earlier, in sunlight. And we get free radicals. These are called chlorine free radicals, and there they are. They're very reactive things. Okay, now what's next? Now, this thing is my methane. And along comes one of these chlorine free radicals. Now, what happens now? Well, one of these electrons goes here between the hydrogen and the chlorine, and this electron goes there as well. So how many electrons do we have now between the hydrogen and the chlorine? We've got 2 electrons, and that's where the HCl is formed. Okay, now the other electron from here goes on to this carbon, and what's formed there? We get this. Okay, so you get these 2 things. Let me move that over a bit. Oh, it moved too fast there, didn't it? Okay, a tiny bit more there. Okay. So, do we understand step 2? Are we good with step 2? The second step is quite confusing. Well done, you're doing a great job. Can anyone see what the third step is? What do you reckon the third step is going to be? by the way, so you might be able to answer better, this is known as a methyl free radical. Or not, radical, yeah, it does. Yeah, the chlorine radical. Well done. You're exactly right. The chlorine free radical. Okay, so let me draw that. So this guy, this my methyl free radical, meets my chlorine free radical. And let's draw the curly arrows. Well, this electron goes there. This electron goes there. And what do we get? We get this guy, which is our product. Okay, which is, what is it? It's methyl chloride. I'm showing my age there. This is what we used to call it. It's chloromethane. We used to call it methyl chloride a long time ago. All right. So that's the mechanism for the chlorination of methane. Timani, have you done this before, by the way, out of interest? Have you done this before? No? Yes? Oh, you haven't? Okay. Well, you're doing very, very well. Janet, are you good so far? Janet's good. Well done. Now, so how many steps are there? There's 3. Okay. But we can quantify these steps, or we can classify them, I should say. All right. And I'm going to use a different color, a nice green. We're going to use green. Now, the first stage that starts the reaction off, this first one here, I'm going to call this 1, 2, and 3. The one that starts the reaction off, the one that creates the free radicals in the first place, this one is known as initiation. Let me get a better pen. Let me get a bit thicker. 3 is a bit thin. This one is known as initiation. So that's the initiation stage. Okay, that starts the reaction off. The next one is when one of the free radicals attacks something and another free radical is formed. This keeps the reaction going. This is called propagation. So the first reaction is initiation. The second reaction is known as propagation. And the last reaction, when 2 free radicals come together to form the product, is known as termination. This is known as the termination stage. So it's initiation, followed by propagation, followed by termination. All right. Now, there are other termination steps. Okay, so let's do a boring termination step first. It's not a very interesting one, but it can happen. A chlorine free radical bumps into another chlorine free radical like this. 1 electron goes there, 1 electron goes there. And what are they going to reform? I'm sure you can see. They're going to reform chlorine. Okay, now it's not very interesting, is it? But it is another termination step. That's possible. What's another termination? Can you see another termination there? A possible termination? Anyone? And if you get a termination, what do you think might be formed? Say, well, maybe you'll be able to see it, but we get a little bit of this chemical, a little bit of this compound in the product. Hydrogen gas. Interestingly, no, you don't get hydrogen gas, actually. It's a good try, though. Oh, that's a very good question. Why don't you get hydrogen gas? Because you don't get any hydrogen free radicals formed. Okay, they're quite high. They're quite hard to form hydrogen free radicals. I know in step 2, hydrogen is pulled away from the methane, but there's no actual hydrogen free radical formed. If we did get a hydrogen free radical, hydrogen gas would be formed, but we don't actually get any hydrogen free radicals. I hope that makes sense. We just don't get them. There's none in front of us. Have another look. Can you see another one? What's possible there? Janet, can you see another thing that's possible? It's a good guess though, Tamani, seriously. But you're on the right track, but it's easier than hydrogen because I'm looking at it now. And when two of these things come together, well done. It's ethane. Well done, Tamani. Janet, can you see how ethane would form? HCl. Yeah, we do. Janet, can we get HCl? Why can't we get HCl? It's a good guess, but why can't we get HCl? Well, we do get HCl, but we don't get it as another thing. We don't get HCl because there's no hydrogen. There's no hydrogen free radicals, aren't there? Okay. But another product possible is this, as Tamani says, when we get, they've gone green on me. Okay, one of the methyl free radicals meets another methyl free radical. There you go, and let's do the electrons. That one. One electron goes here, one electron goes here, and we get ethane. And we do get this. This is one of the products. And if we got ethane, this would also be a termination, wouldn't it? That's a termination reaction. Now, you do get this. We get not much of it, though. We get this in trace amounts. So that means we get very little of it. How would you prevent getting too much ethane? I don't want ethane. I want chloromethane. Any idea how you might be able to prevent getting too much ethane? Again, this is a bit mean of me asking this because maybe you don't know this. But one way we can prevent getting ethane is if we use Oh, well done, Tamani, you're cleverer than me. Next lesson, you're going to give it, okay? I'm going to have a rest. You use excess chlorine. Well done. And this prevents, well done indeed, prevents too much ethane forming. All right, exactly that. Because if you use excess chlorine, you've got so much chlorine free radicals going around that they will meet your methyl radical before two methyl radicals meet each other. So you just do it by a force of numbers. You have excess chlorine, so the methyl radicals don't meet each other, but the chlorines do. Well done. Now, the last thing I'm going to do today, because you've done very well, okay, I'm going to show you how this is shown in your textbook. Okay, shown in your textbook. Actually, you know what? I'm lying here. I don't know. Is it how they show it in your textbook? But this is generally how it's shown in textbooks. And I'm going to use blue. This is how they show it in textbooks. They do this. Cl2 goes to 2 Cl dot. And then they say CH4 plus Cl dot goes to CH3Cl plus HCl, and then they say, oh, that's wrong, isn't it? Sorry, that's rubbish. Get rid of this. Okay, we say CH3 dot, and then CH3 dot plus Cl dot gives CH3Cl. The first one, this one is my initiation, this is my propagation, and this is my termination. And then they'll show you other termination reactions. They'll say Cl dot plus Cl dot gives Cl2, and they'll say CH3 dot plus CH3 dot will give us CH3, CH3. And these are other termination reactions as well, aren't they? Okay. I think my way of showing